Hello everybody, welcome to the pipe flow analysis lab. So basically the objective of the experiment is to be able to analyze losses in piping system, as you can see. The equipment that we will be looking at as far as this experiment is concerned is just in front of you in the form of a video. Basically we are to be looking at the dark blue circuit, okay, and especially we will be looking at the straight pipe, which is on there, which is about 900 millimeters. The spec corresponding to the the dimensions of each one of them is actually given in your lab sheet. So I'd suggest you have a look at the lab sheet, and I'll also take you through the lab sheet as and when we get to the session. We've got measurement points corresponding to each and every section of the pipe. So for instance, we've got a gate valve here. The gate valve is the valve that regulates the flow of the system. The losses between the gate valve can be measured via the gate valve meter, which is right here. The measurement points correspond to the millimeters of mercury. Similarly, you've got a standard elbow, which is that, which is measured. The standard elbow is measured via the units 1 and 2 correspondingly, and you've got a 90-degree miter bend. So the 90-degree miter bend is going to be measured in this location here. And then you've got the straight pipe, which is 914 millimeters in dimension, and a diameter of 13.6 millimeters. So that's the straight pipe here, as you can see. That is basically, that's the point 3, and that is the point. That is the point 4. So if I just zoom back in, so those are the points where the measurements will be taken, and you will actually have a reading in the form of a drop in pressure correspondingly. Okay, so so the blue circuit is what we will be looking at. So the first thing to do is to be able to enable the water to flow inside the system. The water is the liquid that will be used in the system. You will see a tank. This equipment has got nothing to do with us. You will see a tank though. You'll see a collector, and you will see a tank in there. So basically, and then you've got a mass system here. What happens is the water that gets collected into this tank basically tries to tip the lever off. Okay, so you get water collected into this tank, and you will get this lever tipping off, telling you that there is a counterbalance between the weight of the system and the weight that is the weight of the water, or the mass of the water that is collected into the tank here. Now, we would need to specifically say the amount of water that is getting collected into the tank by putting a mass of 15 kilograms in there. Wait for the lever to tip over. So you know that the point at which the lever tips over corresponds to 15 kilograms of mass that has accumulated in this tank. So the time taken for 15 kilograms of mass accumulated in the tank will be measured via a stopwatch, or you can use your phone to be able to measure it. So the moment the lever tips over, I will try and measure the time that it takes to basically collect 15 kilograms of mass. Okay? Then I would know how long it is actually taken to counterbalance 15 kilograms of mass. Now that I know for each turn the rate of flow corresponds to different time to collect the same 15 kilograms of mass, I can then calculate the corresponding Reynolds number using the mass flow rate equation. Okay, and you can calculate velocity because you know the dimensions of the pipe. You can then work out velocity, and then you can then work out the pressure drop calculated from there on. Okay, I'm just going to do one set of reading. Obviously, as detailed in your lab sheet and in your assessment brief, I will be giving you the experimental data, which you will be using to actually get results of the experiment. Now, to start with, I am going to switch the tank on so that the water gets collected on there. So we are switching the tank. We're switching the meter on. So I'm just going to show you in a minute how the water flows inside the system. So as you can see, the water is beginning to flow down the tank completely. It begins to flow down the tank completely. So I want to first of all make sure that the water is getting collected to the system, right? So to be able to do that, what I will do is there is a lever in there. So I want to start, so I will check the lever in so that the water which was flowing down there is no longer actually going to the going to the drains. So it's getting collected in this tank. Okay, so the moment it starts to getting collected in this tank, so I will wait for the lever to tip over and have my stopwatch ready. Okay, the lever has now tipped over, so which means I can start running my stopwatch. Okay, and I've got the time. So then what I will do is I will take the big weight, which is 15 kilograms of mass, and then load it to the system. Now, I will then wait for the 15 kilograms of mass to tip over, and then wait for it to basically tip over. So I'm watching the lever now. So the moment it tips over, I will stop it. Okay, that's the so we've got to, so you can see that the lever is slowly tipping over, and then there's tipped. So basically I've stopped the clock and I've noted the time it has taken to basically collect mass of the water that corresponds to the second weight basically that we've put in through. The first weight basically is just a counterbalance weight. It doesn't tell you anything. The second weight is the weight that I have actually put in through, is the weight that tells you how long it has taken for 15 kilograms of mass, the equivalent of mass that is being collected by the tank in the form of water. Okay, now that we've got a rate of flow going inside, and then now that I've measured the time taken, I've got to untip back. So I'll take the weight off. So it's much easier for me to do it. And then pull the lever back. So I let the water run through. Now, so because the water is running through, it's actually circulating inside the system. Now, this valve here, I can tell you the turns on this valve. Right now, it's about 2.5 turns. I'll try and explain that when I explain this, the system. Basically, you can, the the 2.5 turns basically correspond to the amount of water that you're letting the system in, the amount of water that you are actually letting into the system. So you can start with 1 turn, 2 turns, 2.5 turns, etc. Right now it is at 2.5 turns. So if you turn back, it'll become 1 turn, for example. You can have a 3/4 of a turn. Likewise, you'll have about 5 readings that I would have given you in the form of a table. Okay. So for corresponding 2.5 turns, for example, if you can see the measurement points in here. So we are looking at the gate valves to start with. So the gate valves measurement points correspond to, if you see, that's where the point number, I think it's the gate valve first position, which is X, and then you've got a reading in there which corresponds to about 200 and something, 285, and then you've got a reading down there which is about 160, for example. So that difference is going to be the difference in the form of a loss inside the gate valve. Okay? Similarly, you can measure the one for a standard elbow right here. So the standard elbow corresponds to about 440 something, and then you've got a reading down there which corresponds to about 110. Similarly, you've got one for the straight pipe. Then you've got 420 here. Likewise, you will have 190, which you will note down. Okay, that's for the straight pipe. Again, the last one is the 90-degree miter bend, for which you have a reading of 800 and something and 410. Okay? Now, once we've taken all the readings through, we can then turn the gate valve for a different reading. So now it's about 2.5 turns. So if I do a full turn, if I open it fully, so that will become 3.5 turns really. Okay, similarly, I can take the readings for 3.5 turns. The water, you would expect the water to be flowing much more faster because the valve is now opened up a bit more. Okay, similarly, I'll repeat the experiment. I can start tipping the lever on and start collecting the water in the collector. And likewise, I can carry out the experiments for a number of readings to be able to understand what is the influence of mass that is flowing inside the system in the form of water, and how pressure drop and the loss coefficients have been calculated. So now that it's tipped over, I would have to have started the stopwatch, put a 15 kilograms of mass in there. Now, because the rate of water is flowing differently, because the valve is now opened up a bit more, I would have gotten a reading that would say I have accumulated mass faster in this case because the rate of water that is flowing is much faster. So for the same 15 kilograms of mass, with a lesser turn that is opened up, I would have gotten a reading, I think I got a reading of 1 minute, 7 seconds. Now that the water is actually flowing faster, I would have gotten reading which is much lesser in time, maybe about 70 seconds or something. So, and then I'll start taking the readings once again for a different, for the same turn, which is now 3.5 turns, and carry out the experiments for different flow rates. Okay, and from here on, I will start explaining in your lab sheets how it works. We'll go through a sample calculation just to make sure that we understand how the sample calculation works as well. Thank you, and we'll see you shortly.